Hey everybody, Mrs. Smith here. We are working today on our absolute value inequalities number 4. So again, we're going to solve each inequality, we're going to graph it, and we're going to write the answer in interval notation. So let's start with number 1. We are going to be doing numbers 1, 2, 5, and 6 today. So feel free to watch them all or fast forward as needed. But we will be starting with number 1. So our goal is to get that absolute value expression by itself so we can split it and solve it. To get the absolute value by itself on the left-hand side here, we need to get rid of that negative 5. So right now the negative 5 is multiplying here to the absolute value expression. So let's divide by the negative 5. Okay, so that's going to just equal 1, cancel out. So we're left with the absolute value of 2 minus 3x is greater than, wait a second, we just divided by a negative. Sounds like we need to flip our sign, doesn't it? Okay, let's make that less than, and then negative 25 divided by negative 5 gives us 5. All right, cool. So now is our absolute value expression by itself? Yes, it is. It looks like we're ready for the next step. So we need to split this guy into two separate things. So we're going to do 2 minus 3x is less than 5. And we're also going to do the negative version of that. So negative, make sure you use parentheses here, 2 minus 3x is less than 5. Okay, let's start by solving this one. Get rid of that 2 first by subtracting it from both sides, and you're left with negative 3x is less than 3. And then we divide by negative 3. And see, I'm going to remember this time. Here we go. X, and flip the sign. See, I remembered. Yay, I'm so proud of me. X is greater than negative 1. And there's nothing else we need to do there. X is greater than negative 1. Okay, let's look at this other side. We've got this negative out here in front of the parentheses, so let's just get rid of it first by dividing by negative 1. So if we divide the whole thing by negative 1, we're going to get 2 minus 3x, flip the sign, and so greater than negative 5. Now we will subtract our 2 away, and we're left with negative 3x is greater than negative 7. Now we have to get rid of that negative 3 by dividing it. Looks like we're going to be flipping that sign back this way. So x is less than 7 over 3. Okay, let's go ahead and get that put on the graph. So if x is greater than negative 1, let's do our circle. We're doing an open circle because it's not or equal to. It's just greater than. And it's going to go up that way. And we have x is less than 7 over 3. So let's see, 6 over 3 would be 2. Looks like we're going to go just a little bit further than 2. And another open circle. And it says x is less than that, so we're going to be going down this way. And basically, we just want that area where it meets in the middle. Okay, and now when we have it looking like this, where you have 2 dots and it meets in the middle, that's where you use the word and. So let's write the word and here. And so we have x is greater than negative 1 and x is less than 7 over 3. Now we only need our interval notation and we'll be all set. So on the low end we have negative 1 and on the high end we have 7 over 3. They're both open circles, so let's use our parentheses and then we'll just make our answer a little bit more visible. And we're done. Okay, let's go on to number 2. Number 2, we have 3 plus, and then we have this whole absolute value thing, is greater than 5. So the only thing we need to get rid of here before we split it into 2 separate expressions is that 3. So let's get rid of it. Let's subtract it. You're left with absolute value of negative 10 plus 4v is greater than 5 minus 3, that's 2. And now we're ready to split it into 2 things. So let's do that. I'll put one of them down here. Negative 10 plus 4v is greater than 2. And we're also going to have the negative version of that. So negative, parentheses, negative 10 plus 4v is greater than 2. Okay, let's solve this one first. Getting rid of that 10, we'll just add 10 to both sides, which gives us 4v greater than 12. Then dividing by our 4, v is greater than 3. Okay, looking over here on this side, the last time over here we had the negative in front of those parentheses, we divided through by the negative. And that would work here also, but just in case you want to look at it a different way, let's try distributing that negative this time. We have parentheses now, not absolute value bars, so it is okay to distribute if that's what you like to do. So negative 1 times negative 10 is 10. And negative 1 times positive 4v is going to be negative 4v is greater than 2. Let's get rid of the 10 by subtracting on both sides. 2 minus 10 is going to be negative 8. And then we have to divide by that negative 4 and flip our sign. So v is going to be less than negative 2. Excuse me, I did that wrong. Negative 8 divided by negative 4, so v is going to be less than positive 2. Just scribble that out and we're all good. Okay, so let's get this on the graph. V is greater than 3. It's not or equal to, so I'm just going to do a nice open circle and we're going to go up this way. And then v is less than 2. Again, open circle, and we're going down this way. Okay, it looks like they don't meet in the middle, so we're just going to go all the way out to the arrows, reaching to infinity on both sides. And when you have it going opposite directions, that's when we use the or. So I'll write a nice or right there. So v is greater than 3, or v is less than 2. One step left, that's our interval notation. So starting at the lowest number, going on forever this way, that's going to be negative infinity. And it goes up to 2 and stops there. We have that open circle, so that value is not included, so we're going to use parentheses there. And parentheses here, because you always use parentheses with infinity. And then we write u for union. Next up we have a 3, again parentheses there. Going up forever to infinity, so another infinity there with parentheses. And then all of this is your answer, along with your graph, of course. Okay, good work, guys. We're on to number 5 next. Alrighty, so here we go, number 5. This time you have the absolute value expression in the top half of the fraction. And then the bottom half of the fraction is not part of the absolute value, so you really got to get rid of this first so that you have just the absolute value expression there. To get rid of that 2, we're going to multiply by 2 on both sides. So these 2 cancel out. Basically, it becomes 2 divided by 2, and that equals 1. So that cancels. And then we're just going to copy 6x minus 6, or the absolute value of that, is greater than, and we multiply that. 2 times 2 is 4. So now is our absolute value by itself? Yes, it is. Awesome. So let's go ahead and split it into 2 different things. We'll do 6x minus 6 is greater than or equal to 4. And we will also do the negative version. So negative 6x minus 6 is greater than or equal to 4. I'm going to solve this one first. Add 6 to both sides. You'll get 6x is greater than or equal to 10. And then x is greater than or equal to 10 over 6. Now 10 over 6 is a fraction that can be simplified. If you divide both the numerator and the denominator by 2, you're going to get 5 over 3. So that's what we want, the most simplified form. Okay, now let's go ahead and do this one. Which way did you like better up here? Dividing by the negative 1 or distributing through? I'm going to just divide by the negative 1. So if you divide both sides by negative 1, you're going to be left with your 6x minus 6, oops, I divided by negative 1, I better flip my sign, right, is less than or equal to negative 4. Let's get rid of the 6 by adding it. So 6 is less than or equal to negative 4 plus 6, that's 2. And now we've got to divide by 6 on both sides. So x is less than or equal to 2 over 6. Again, this is a fraction that can be simplified. Let's divide the numerator and the denominator by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. And now we have a nice fully simplified fraction. Let's go ahead and get this on the graph now. X is greater than or equal to 5 over 3. All right, so let's see. 3 over 3 equals 1. 6 over 3 equals 2. So 5 over 3 is going to be sort of right in here. We're doing a closed dot because it's greater than or equal to. And we know that it's going to kind of go off that way. Now we have x is less than or equal to 1/3. So 1/3 is going to be between 0 and 1, a little less than halfway. So I'll put mine right there. And it's going to be less than. So we're going this way. It looks like we're going to go to negative infinity on one side and positive infinity on the other because they really don't meet up in the middle. And when you have a graph that looks like that, it's going to be an or. So I'll write my or right there between this and this. And now we just need our interval notation. So starting at the low end, the lowest value here is our negative infinity, which it never reaches because infinity goes on forever and ever. And it goes up to, that's 1/3 there. 1/3 is included because you have that closed dot, that less than or equal to. So let's use our bracket. And then we write union. Another bracket here for our 5/3. And from there going up to infinity again. That is our whole answer. I'm just going to, well, here we go. Kind of a little messy there. I hope you guys can read that okay. And let's do number 6. Again, if you feel ready, go ahead and do your assignment. If you want to keep watching, that's awesome. Keep watching. We got to get rid of the 7 in the denominator, so let's multiply through by 7. That crosses or cancels out, and you're left with absolute value of negative 6p plus 1 less than or equal to 1 times 7 is 7. Now we have our absolute value expression by itself, so we can go ahead and split it into 2. Negative 6p plus 1 is less than or equal to 7. And then our negative version, let's use our parentheses. All of that is going in the parentheses. Negative 6p plus 1 is less than or equal to 7. Okay, so let's solve this first. Subtract 1 from both sides and you get negative 6p is less than or equal to 6. And then you divide by negative 6. You flip your sign. And you're going to get negative 1. P is greater than or equal to negative 1. Let's see what happens over here. Let's see, last time we divided by negative 1. Let's keep it even. This time we're going to distribute. So that negative distributes in. So negative 1 times negative 6p equals positive 6p. Negative 1 times 1 equals negative 1. So it's going to look like that. No need to flip your sign. You distributed with a negative number, but you did not multiply both sides by a negative number. So you do not need to flip your sign here. That's just going to be a 7. Let's get rid of that 1 by adding it to both sides. So 6p is less than or equal to 7 plus 1 is 8. And p is less than or equal to, dividing by the 6 there, 8 over 6. Now is that fully simplified? Now we can divide both that numerator and that denominator by 2, leaving you with 4 over 3. So p is less than or equal to 4 over 3. Okay, next step. Let's get it on the graph. P is greater than or equal to negative 1. Greater than or equal to using that closed dot, and I know I'm going up this way because it's greater than. And then I have p is less than or equal to 4/3. So let's see, 3/3 equals 1. 4/3 is going to be a little bit farther. There's a closed dot, and we're going down this way. All right, and what's left? Oh yes, we need to write either an and or. When you have them connecting in the middle, it's going to be an and. Here we go, and. And finally, interval notation, we're almost there. So negative 1 on the low end, 4/3 on the high end, and we have closed dots on both sides, so give it some nice square brackets. Make your answer look nice and neat, or at least neater, right? And you're done. Thanks so much for watching. Hope you guys have a wonderful day. Bye.